All right, we're continuing to chapter 3, and this is part 3 of chapter 3. So let's go ahead and fast forward over to slide 25, I believe it is. Yep, typecasting. So what we've talked about in previous videos slide with coercion and when you're using equal signs in your or you're using operands that C plus will kind of do behind the scenes for you some auto casting for you. That's kind of known in the world as implicit casting. And we're going to talk a little bit more about implicit casting, but we're also going to talk a little bit about explicit casting, where we, as the developer, we actually tell C++ what we want to be how we want it to be casted. So let's talk a little bit about typecasting. It's used for that manual data type conversion, also that explicit. We are explicitly telling it how we want it to be converted. It's useful in floating point divisions using ints. So in this little example, we're actually going to throw this up in some code. Y2, Y1, X2, and X1 in this, imagine they're ints, just standard ints. But when you do the math, because you've got the division in there, you can quickly get a floating point. And if you don't allow for the floating point somehow, remember what we've said, C++, because you're already using ints, will just continue to use ints. And if you don't do some kind of manual conversion, say, no, it's okay, go ahead and let this become a double, which allows for the floating point, it won't. So let's take a look at that. I've got a nifty little program up here. Here we've got the example. We've got 7 as our x1, 3 is our x2, 4 is our y1, and 5 is our y2. We're going to just allow it to do its thing and output to the console, but then we're going to have it do its thing, but we're going to tell it to go ahead and do a static cast on it to a double and put that into the variable m, and then just output m. So as you can see, we have 0. And that's because we don't allow for that floating point when we just let C++ take over, and it will continue to use the ints. However, when we allow for the casting, all of a sudden, now we get a little bit more precision. We get a little bit, and by the way, a more accurate answer. So you always have to be careful when you get into situations like this. And this is a place where oftentimes we do get bugs because we don't think this through. We don't realize the math could produce something that we need to cast at. And so it just happens. It's one of those things, and you'll deal with it. But this is definitely where you'd want to see a static cast. Also very helpful. So remember we were talking about chars are actually just nothing more than behind the scenes than a value. So if you wanted to actually see what that value is, you can static cast it to an int to see what that, I believe we can call it, I think it's the ASCII chart for C is. And so we're doing a static cast to int char. Now let's take a little example of a typecasting program. And again, we're asking for books, months, and then we're going to average the number of books per month. Now, see, this is giving us some nice, good comments out the side. And so we're going to ask the user, how many books do you plan to read? And then how many months will it take you to read them? Well, we already know that this math is probably going to produce a floating decimal. So that's why we want to make sure, because it's ints, we're asking for ints. We don't want to ask for doubles because, remember, we want to make sure that we are setting the input when we're doing CN, whatever we're looking for to get from the user, we need to make it that type. So that's why we're using ints. But this math is going to create a floating point, more than likely. Not always, but it could be an int. But let's go ahead and static cast it to a double. So that way, when we put the data out, like in this case, you can see that is 4.28571 books per month. Makes more sense here. So this is a great example of that. All right, so this is going to cover a little bit, and again, remember there are multiple ways to develop in languages. Oftentimes, I will also, especially when it comes to just kind of this coding standard, your style for development in languages. Each language you develop and you'll have your own kind of style. And like I said, a lot of organizations will have a style for you too. They like to prescribe a certain format and style, so that way all their developers are developing code that looks similar and not all over the place. By the way, I can tell you, even with all of that, each developer still has their own style and can change things slightly within the organization's style guide. And I can tell you, like I said, I manage a development team, and I can look at code and often tell you who wrote a piece of code based on the style, the tabbing, the way they break lines, because I get used to kind of reading their style. Just like with if you continually read a certain author's book, you get used to their style. Same thing with developers; they tend to kind of have their own style. So let's talk about the next section, the multiple assignment and combined assignment. What this is saying is that when we do multiple assignments and combined assignments, that's fine. You can do that. X equals Y equals Z equals 5. And you will do this at times. Obviously not probably as simple as this. I mean, I've seen it. But this is a good example of it. The point to this is we always read, when it happens like this, right to left. So 5 is going to first go into Z, and then Z's value, which is now 5, is going to go into Y. And then Y's value now is going to go into X. So associates right to left. And they actually add a little bit of parentheses here to try to help you understand how that goes down. Combined assignment. So look at the following statement. Sum equals sum plus 1. Now, I believe it was the last video, we did this. We said sum equals sum plus 1. This adds 1 to the variable sum. We also then changed this up, and let me bring my little handy dandy thing over here, and just so we can say, so they're saying it's sum, right? And then they're saying sum. Let's just give it, sorry, the good developers give it an initial value, initialize it. Then we're going to say sum equals sum plus 1. Well, we've already discussed another way of doing that is we can also do sum plus plus. That's a shortcut. But you can also do some more shorthand, and we're going to see that here in a second. So here's some. So what they want you to do in this chart is they want you to assume x is 6. X equals x plus 4 adds 4 to x, so it's going to be 10, and so forth and so on. Even modulus here, if x is 6 and x modulus 4, well, 4 goes into 6, 1, leaving 2 as a remainder. So that makes 2 as the value. But with that being said, we can do a lot of shortcuts. And the one we just talked about, that's a good one. But we can also say sum equals plus 1. And the reason why this one's a valuable one is because what if you want to do more than just increment? What if you're want to add 5? You can use this. You can't really, there's no such thing as doing, that doesn't work. What you would do is you use the second shortcut that I just showed you, which is sum equals plus 5, and that works. So there's another shortcut. In fact, here's a whole bunch of shortcuts, and they work great. And a lot of people now, definitely the plus equals, the minus equals are the most common, right? And I would even say that looking at this chart, common to least common, it's sorted in common to least common order here. We definitely tell people to be careful with decrementing, right? Because incrementing, when you talk about numbers, they go kind of from 0 up, right? Now, yes, in reality, and for sake of science and math, you can go zero and you can go forever the other way too, right? But oftentimes in reality and programming, um, we are always, start no, excuse me, let me rephrase it. Oftentimes zero is the bottom, right? So that's why incrementing, you hardly ever get in trouble. It doesn't happen that often. What we tell people is when you start getting in decrementing, where you have the y minus equals 2, you may run into problems quickly. So again, the plus equals, we're going to see that all the time. The minus equals a little bit more often. And for some reason, the multiplies equals, we just don't see it that often. And it works. It works great. And there's not a whole lot of trouble you can get it. I guess you could get it away, if you're creating a loop and you're using that. But again, whether you're using this or z equals z times 10, it doesn't matter. If you're in a loop, you're in a loop, right? But I just don't, at least in my experience, I don't see it that often. But it's great. It's usable. Use it. This notation, I don't think I really have seen that in notation. Not that you can't. I just haven't seen it in my experience. Same thing with the modalist. I don't think I've ever seen modalists used this way, even though absolutely you can. So feel free, if you do that in your code, I probably going to give you even some kudos because, again, it's not something that you'll be seeing. Now, again, you may find yourself in an organization that doesn't even have a rule around this. You then use one of these more uncommon ones, and then all of a sudden your organization will come up with a rule about not using it because it's just not common. It may not. They may be fine with it, but just wanted to give you a heads up. Like I said, just not as common as the plus equals, or even to some degree the negative equals. All right. Well, when we get into the next video, we're going to talk about formatting options, and I believe that is our 3-7. Nope, we have 2 more videos for this chapter. So next up, like I said, is the formatting. And we'll see you there.